So I don't want to drill through that if I don't have to. So I could move laterally through the joist over to here. Got a little while to go on the cisterns. Today is super exciting for us. You guys probably will share in that excitement. We're finally getting moving on some house projects. It's been a little bit of a rest period and adjustment period. Of course, we have a new addition to our family, which is freaking exciting, but it's been a bit of an adjustment. You know, we're used to kind of going like crazy. You guys know, you've been watching this channel. We've been going hard, we go at our own pace, we dance to our own tune, and we really got acclimated to that pace, even though it killed us. Fair enough, and we needed the winters to somewhat lick our wounds and try to find our souls. But that was kind of the norm. You know, we didn't want it to be that way. That's just the pace that was required to do what we do. And we've taken some rest time. I won't call it downtime because we're just as busy as we've ever been. There's just other stuff to work on. And anyway, we're back at it. Today, I'm working on electrical. That's not completely true. I've been working on electrical for weeks. A lot of planning and kind of hashing out the finer details. I want to communicate again that we didn't get this far into the house with no plan. But sometimes the plans are not granular enough for people like us to extrapolate exactly what to do. I don't want to say that we need like an IKEA set of plans because that's probably a little too harsh, but we do need a little bit more detail. Okay, and we didn't have that detail. So I've been working hard on getting that stuff done and really drawing it out so that just about anybody could pick up this set of plans who has at least a shred of building experience and can work out what it is that we expect to happen. Pretty soon we're going to be pulling wire and working on getting electrical into the SIPs. But I've got an electrician who's scheduled to come by soon, and he's going to walk through this project with me again. And we're going to kind of talk about the way we have our circuits laid out, where we have switches, where we have outlets, and make sure that that's all going to work. And then probably the most important question I'm hoping to answer or just review is running electrical or anything really through our floor framing. You can see that we've already got some wiring in there. That's from the garage door opener and the sensors that it needs to work. But this is a kind of, I don't know, how do I say this? In my experience, the only people who care about the engineering on the I-joists is the engineer. After that, pretty much everybody, every other trade who comes in, they just start punching holes. You know, it's like, what's the shortest route to get this from there to there? And I've done quite a bit of research and I have seen some gross exaggerations of over drilling these I-joists. They're an amazing engineered wood product that can span long distances and give us freedom in construction that maybe we wouldn't have otherwise, but there are limitations. The manufacturer actually publishes a table of acceptable holes, and I've highlighted the joists that we have here because there are many different series and there are many different heights of joist, and basically it comes down to the thickness of the flange and the thickness of the webbing, and that's how they create these different joists. So we're using a 360 series that is an 11 7/8 joist. And so here it tells us the size of hole that we can drill and how far we actually need to be from an area of support. When we put our SER in, people were kind of panicked because they saw us drilling very close to an end bearing to route that SER cable. So many of the holes that we used were factory holes, and then we just added a few to complete the run. So anyway, our holes are outside of these hashed areas, but these hashed areas are extremely important. We cannot drill within those areas. And then we cannot drill any hole anywhere. There's a certain distance a hole has to be drilled from a support and then from an adjacent hole. And the bigger the hole, the farther from the support and the farther from the adjacent hole. In residential light construction, the biggest hole you probably need to drill is about 1 inch. Okay, maybe 2. There just isn't really a lot of big holes in electrical. I'm not worried about the electrical holes though. I'm worried about plumbing because we're probably going to have a 4-inch main coming down from upstairs, I'm assuming. Maybe 3, I think actually would probably be more appropriate because of the toilet, or toilets plural, and HVAC, which we haven't even got to that stuff yet, but we will have some ducting running in the floor members, and we've really got to think carefully about where we poke those holes. So with the electrician, I'm hoping to go over that stuff and feel optimistic and conservative about where we're routing our wiring and making sure that we're not setting ourselves up to have problems down the road with these other trades. To make me feel more electrically, I went out and I bought a bunch of boxes and switch plates and breakers and things like that. Statistically, half of this stuff is going to get returned because that's just how these projects go. Using the experience that we had from the circuits that we've already put in the garage, I doubled up on everything that we already had using my electrical plan, and I'm hoping that I have enough to get most of the way through the project before I have to return a bunch of this stuff and replace what we bought wrong. If you haven't seen the earlier electrical videos a few months ago, we'll link to those in the description below. Go back and watch those. We're building a very unconventional home. Because of that, pretty much all the stuff at the hardware store is useless. We don't have stick framing in most of the house, and we have shallow depths, for example, on the foam walls behind me. These are an ICF block. They're 2 inches deep. So we can't use a lot of the 21-cent traditional single and double gang electrical boxes. We have to buy the $4 box, which is actually less plastic but costs 20 times as much. So if you give those videos a watch, you'll see that there's a lot of really non-traditional ways that we're going to be doing things. We're going to be modifying boxes. We're going to be using things like mud rings on J boxes instead of using like a double gang box that you might be more accustomed to seeing. Stuff like that. We're going to have to kind of hack these boxes up and remove these nails and use these flanges. So I have enough stuff that what I'd like to do is work on just getting things laid out. That's really, I think, for me, how I process electrical is I start with where the boxes go, and then I work out where the wire needs to go to get to the boxes. One, two, three, 4, 5, 6, 7. Six, 7. And let's see, the ones in the front are, let's see, the first 3 are B's, and the back 4 are A's. B for boy, or Bravo. And a Bravo, and a, can I get a Bravo? 1, 2, 3, 4, 5, 6, 7. Nice. At first I was thinking that every 4 feet was a little overkill for double outlets, but you know, I'm not really sure. I think you can have not enough outlets. I'm just not sure you can have too many outlets. And we're gonna set these at 4 feet because there's a good chance we're gonna end up with some cabinet space over here. And we wanna make sure that these are above countertop height. All right, so that circuit then comes over here, kind of beside the stairs. But we don't have the wall there yet, so we have some singles, let's see, by the buttress, on the buttress, and then kind of behind the brewing and canning stuff. At some point in the future, we're planning on closing in some portion of this space underneath the stairs. So we're not going to get too heavy into wiring this side. We do want to bring outlet power over here, and I think we should have some sort of light power over here. That way we can put a light in there or whatever we need to do. But that's pretty much all we can get done in this area right now. And then when that wall manifests itself magically someday, might be built by us, and then we can kind of worry about what else we want to put in there. Kind of seeing now that I forgot to put a home run on here. So this stair lighting is actually going to be wired into the garage lighting circuit, so that if we trip the lighting circuit upstairs or something like that, these lights won't go off, and we can come down the stairs lighted to the breaker panel over here at the mechanical room. So I need to draw in how that power is going to come over here, because that's where we're going to pick up the lighting circuit to light this storage area, versus trying to run another home run from the panel. We'll just pick it up wherever the stair lighting grabs its home run from. These boxes over here, for some reason I think we were putting those at 3 feet because there's not going to be any cabinetry here. Now we're getting into the fun stuff. So by the door here, we actually need to have an outlet on the outside and on the inside. I was going to put an outlet on the outside in this here, but our drawing didn't include that post. It looked way more doable on the drawings than it does here. I think for life simplicity purposes, we're going to bring that outlet down, and then we're just going to jump from the inside outlet to the outside outlet. And that's, I mean, that's as easy as it gets, you know, versus having to bring power from down here up and over the door and then down and over there. I guess that's me complaining about how difficult it is to build something versus the usability in the long run. But let me share a little bit more of an insight. There's got to be a hydrant somewhere. And so we want to put a hydrant in this wall to the outside. So there's going to be plumbing exposed right here. And I don't really want to be running electrical and plumbing and all that in this SIP. And that means that, you know, between the door on the garage door outside, there's going to be an outlet. I guess if we live with it for a little while and it turns out to be a pain in the butt, we'll figure that out. And this one, I think we're going to go pretty close to the floor. We're going to go 2 feet high. So, and we're going to go a single here. And that's going to be on the voice circuit. This is where it starts to get really interesting. We've got switches and things that need to go in here, and we're going to put those at 4 feet. But I think we're going to have to get creative because there's a piece of lumber in here and a piece of lumber in here. So we have only this much usable SIP that we can actually modify. And in an ideal world, we wouldn't modify the whole thing. So at 10 inches, if we lose 3 inches to the lumber, 1.5 inches on both sides, we've got 7 inches in the middle of this thing where there's actually meat. And if we cut a huge 7-inch hole in here, I mean, that really diminishes the strength of this panel. It'll be one of these. Seem awfully deep. What are these? 48. Wow, that's a monster box. I wonder if I have any other. Oh, here we go. See, look at the difference, guys. Look at that. 32 and allows 14 number 12 wires. That's quite a bit. And this one's 48. I'm kind of worried at how deep that is. I mean, well, I guess we don't have this on the inside and the outside, just on the inside. So we're going to lose 4 inches of our SIP by cutting a hole back there. So our energy efficiency where this box is going to be drastically reduced. So that's 4 inches deep. This one's 3 inches deep. So if we can, we'd like to use a more shallow box if it'll allow us to do what we need to do. See, there's kind of a trick there. So these boxes are actually not even the same height. Even though the mounting holes for the outlets are the same, they've kind of fattened it a little bit. You can see this kind of extra space up here. They do that to get more cubic inches in the box. If you don't understand how they mark boxes, watch some of our earlier videos and you'll see that we explain some of these markings in the back of the box. They actually tell you exactly how many wires and what size you're allowed in a box to meet code. So they've done a lot to get this box to 48 cubic inches. They've made it taller, deeper. So I think if we can, I think the point of this is like, let's use something as small as possible to do the job. If I'm an electrician, I'm gonna use the biggest box I can get away with because it makes my life easier, because shoving wires in a small box really sucks. But in this situation, on an exterior wall, where we're trying to maintain insulation value, depth starts to become a factor. So out of curiosity, so this box at the face is a 4-inch box. So that leaves us just 1.5 inches on both sides between where the box ends and the lumber begins. So at 4 feet, our box is gonna look something like that. And then it gets interesting because we actually need to have 3 switches in here. And if you're paying attention here, there's only 2 gangs, right? There's only spot for 2 switches. But what we're gonna use is probably one of those really annoying switches that actually goes left and right like this. They kind of look like an outlet. And then we could do 1 switch here, like that, or something. Maybe make this the exterior lighting, and then this will be garage bank A and then bank B or something like that. That's gonna come up and over. Well, it's gonna come up and there's gonna be a light outside this garage door, a light over the door, a light next to this garage door, and then one on each side of the outside edges of the garage doors. And like I said, I think we'll control that from that switch. If you're not sure how that's all gonna work, see these paint markings. If you've been watching this for a while, you know what they mean, but this means that there's actually a chase inside this panel. This means it's a vertical chase and it tells you where it is. It's supposed to be right there. Although when we were building this, we kind of found that the chases were all over the place. And then there's a horizontal chase here, and that's actually at the code height or normal height for outlets. This is above normal. So but because we're not going to put anything down here, we can basically run power down through that vertical chase to this outlet box, and there's nothing below it, so it doesn't really matter. So that's how we're going to get power in here. We're going to run it through that vertical chase down to here, but then we've got to have power going back up, and it's got to go back out because this is going to be controlling the 2 banks of interior garage lights and then the exterior lights. So that chase in there, I don't know what's going to happen. So there's a code for the maximum number of wires that are allowed in a particular hole. And I think it has roots in heat or fire. So if you were to use the circuits at maximum for a long period of time, those wires would build heat. The code says for a 1-inch hole, you're allowed 3 wires. I don't know if there's a limitation on the size of the wire, but let's just pretend like there's not. If we've got power coming down here to the outlet, that's 1 wire. And if we've got another wire coming down here to provide electricity or a home run to these switches, that's 2 wires. And then we've got a wire from each of these going back up. That's going to be 3 completely different circuits. That's 5 wires, and there's only 1 chase in this panel. I think that's a situation where either we'll see what the electrician has to say. He may have some advice on that, but it's kind of a non-traditional construction method, so I don't know what'll happen, but maybe we should contact the inspector first, kind of put the scenario to him and see what he thinks. Okay, so we got this side marked out. We've got our outlet here, our switch here. Looks like the only things that we're missing is these 2 posts. Each have an outlet on them. And then it's time to go outside. In situations like this, Alyssa and I usually just kind of lean on ergonomics. Like, what is the flow of the building and what kind of makes sense? So the door obviously is over there, and my pin kind of represents the traffic flow. Assuming we actually park cars over here, you know, you're not going to be walking a lot on this side, but you're going to have cars coming in out of here, so you don't really want anything sticking out over here, and because you're walking over here, you don't want anything sticking out over here. So that leaves us 2 sides. We can mount an outlet to this side or to this side. And I don't think there's really an obvious answer to that question. If we have the outlets on the inside of the post, I guess you're more inclined to use the electricity between the 2, but if they're facing outside, maybe you're more inclined to use them the other direction. I don't know, maybe we're putting too many outlets in here, which is why this is starting to sound like a philosophical conversation about outlet placement. I guess we got to make a decision on which side the outlets are going to go and then get them marked. If you've ever seen the show Who Wants to Be a Millionaire, when you find yourself in a situation like this, you have a few options, and one of those is to phone a friend. So what we're going to do is we're going to name this side of this post Apple, and then we're going to name this side of this post Banana.
Howdy.
Hey, I have a quick question for you. Apple or banana?
Apple.
Apple? All right, that's all I needed to know. Thanks.
Okay.
All right, see ya. All right, so we've got one Apple, but everybody else is saying, call me in a little bit. So we'll kind of put that project on hold for a minute. I guess we'll have to wait until we get in. Wait, my phone's ringing. Oh, we got one. We got one. Hey, love, I was just curious, Apple or banana?
Banana.
Banana? All right, that's all I needed.
Yeah, okay.
All right, thank you.
All right,
Bye.
bye.
Guys, this just got interesting because whoever calls me next is going to be the tiebreaker. So there's actually going to be a light on over the exterior door on the outside, and then one light on each side of each garage door. Kind of thinking ahead to how to make that work, this horizontal chase in this panel is basically at the bottom edge of that header right there, and it doesn't make sense really to try to come down, like come up from the switch and then over and then down to a light there. That could get pretty difficult. Definitely gonna have to drill some holes in the SIPs. Let's kind of go outside and take a look at what that looks like. So we're basically at the bottom of the headers over the garage doors. So that would put our exterior lights up here, or at least the box would need to be up that high. But in my mind, I feel like those lights maybe need to be a little bit more beside the garage door. And this one for sure, unless it's just going to be a straight down light, which I think we're going to do something like a stagecoach light or a sconce light or something like that. I've been kind of just looking at this for a minute, and I just feel really strongly that these lights need to be fairly low. The real challenge with that, especially with this door, is that there's no vertical chase in that panel that I know of. In this panel and all the other vertical panels beside the garage doors, there is a vertical chase. So we can come over to whatever degree is necessary and then come down that panel to the box location. And I'm kind of feeling like those lights need to be basically lined up with the glass. Hypothetically, we could move that screw, we could move it down and maybe put one above and below. So let's go with the middle of the glass, which is going to be 97.5 inches. It'd be good to have that conversation with the electrician and make sure there's not something I don't know about with either code or what standard or whatever. But that's going to be kind of a problem over here because that vertical or that horizontal chase in this upper panel is clear up here at the bottom of the header. We can't exactly put a box right out here. Although that's, I think, where we actually want this box is pretty close to the intersection of those two black lines. Something in line with the lights on the garage, I think, aesthetically makes a lot of sense. We have a deck that's going to go up here. We can't have it too high, otherwise it'll intercept the deck. And then let's get the light marked over here, and that kind of does it for these three lights anyway. All right there. And then we have this outlet, which is a single outlet out here. So it's going to be at 24 inches high, and this will just be a single gang. I feel like the issue with this panel is that there's only that one chase, and in theory it's in the middle of the panel, and I think it's a 1-inch chase. This panel is 8 inches thick, which means that there's, 3.5 inches of foam on either side of that chase if it's actually perfectly in the middle. And these boxes, what did we say these boxes were? I think they're 3 inches deep. So that leaves us only about a 1/2 inch of foam. But I guess hypothetically, if we put a 3.5 inch deep box there, it's not going to intersect the chase. So there will still be room behind that box for that wire to come down. We have taller than normal garage doors. We have 9-foot garage doors. And I feel like that puts the lights a little higher than they feel right. If we had a lower garage door, these lights would probably feel a little too high, but let's leave it like that and we'll see how it goes. So on the topic of lights and kind of bouncing back to where we said this is a non-traditional house, and it's presented a lot of issues with how to mount boxes and stuff. And with the lights, it kind of is another, it's just another problem. So this box is actually what's called an old work box. There's actually two basic categories to boxes. They call them new work and old work. And there's a few different fastening or attaching methods among each. This one being an old work box, it has these little wings on it. Basically, you slide them in, you slide the box in the hole like this, right? And then as you turn the screw to tighten it, the wings flip out and they have a stop, so they can't move anymore. And then as you do that, you're actually pulling this wing towards the wall surface, say sheetrock, or in this case, the OSB that makes up the SIP. And it's got 3 of them all the way around. So that's what would physically hold this box in place, would be these 3 wings. And it's not terrible, but it doesn't feel great. If you're hanging a fairly heavy light from that box, I guess you're just relying on these screws and those threads to hold that all together. So if we jump to metal boxes, there's lots of options in the metal category. I was able to find these boxes that actually have metal wings on them. And these wings, if you look closely, they're actually reversible. So you could actually flip this over and make that wing basically flush with the face of the box. And it's a much more stout box. And the fastening method is actually through the face of the SIP itself. And you have 4 attachment points. I'm not going to commit to one of these boxes yet. I want to talk to the electrician and see if there's maybe a limitation with one of them. With the metal boxes, there's actually strain reliefs built into them to bring cable or wire in through the sides. And then the plastic boxes actually have these strain reliefs built into them here. It gets to be difficult because we can't, you have to put the wire into the box and then hold onto the wire and slide the box into place because we can't reach into the wall, right? So with those lights, this is gonna get to be a problem. I guess once we figure it out, we'll know. But it's gonna be an issue on everything that we do that mounts in the SIPs. We're pretty much done with kind of marking where things go. We haven't done anything in the ceiling. I'm gonna do that probably tomorrow or another day. What I would like to get done with today is getting a lot of the busy work done with these outlets on the east and the west walls. I'm 100% confident where those outlets are gonna go, and it's just really tedious work. I don't need the electrician to oversee that part, so I feel like that's a good kind of way to end today. I don't want to cut into the SIPs until I'm 100% sure where those lights and boxes and switches and things are gonna go and kind of how all that wire routing is gonna happen. We kind of came up with a poor man's hot knife system when we were working last winter on getting our first electrical boxes installed, and it worked good enough that we're gonna keep doing it. 7 down, 6 to go. Well, I think getting all the outlets in these things was a lofty goal for today. It's not gonna happen. I think bit off a little bit more than I could chew maybe. It does feel good though to get a lot of this kind of layout done. I think the planning was time consuming and tedious in my mind. You know, it's just how the process goes. And then kind of working through the layout, physically looking at the house, kind of where you've drawn things and making heads or tails of how that works. And then of course getting a little bit of work done today. All that feels really good. I've got a little bit of a push to do, kind of have that deadline. Like I said, we have an electrician coming by in a few days to kind of look this stuff over with me. So that's my motivator right now, and kind of got to keep moving forward. Still a long way to go before we can get rid of all these extension cords, but we made a lot of progress today. This is all finally kind of becoming a reality instead of just a bunch of erased pencil marks. Things I can still work on before the electrician gets here is getting the boxes and things installed in the ceiling. So I think that's next up on my list. And then of course, doing all the busy work. Oh, I almost forgot one thing. Some of you are probably wondering, why am I using a piece of plywood? Let me show you. On the boxes on the other wall that we already installed, we hot knife these things full depth. That's 1.5 inches, and this foam is 2 inches deep, which left us somewhere around 1/2 inch of foam behind that box. So of course, the concrete behind there is getting closer and closer. We'd really rather have more foam if we can. So the plan for this wall is to put sheetrock over the foam for fire. So we have a fire barrier between the garage and the foam. But for utility purposes, at this point, we're planning on putting 3/4 inch plywood, finished plywood, and potentially using a stainless steel wainscot on the bottom for protecting it against bashing and cleanliness and things. So going forward, we're actually going to be setting these boxes to the depth of the sheetrock. So we're going to be actually installing this through the sheetrock, which is going to be 1/2 inch. So the boxes we already installed on the other side, we'll need to foam behind them and pull them out and mount them to the sheetrock. That does a lot of things for us, a lot of benefits, and that's why I'm using this piece of plywood. Howdy.
Okay, I can't text, I'm wearing gloves.
Gotcha. So apple or banana?
Apple, wholeheartedly.
Apple. All right. That's what I needed. Thank you.
You're welcome.
Well guys, that settles it. The outlet is going on this side. But I think to kind of balance the yin and the yang of the garage, we should probably put the outlet on this side, on the other side. So we'll put that outlet over here. It's just not gonna happen today though. Time to clean up, get some dinner, and hit it hard tomorrow.